So you might want to punch me in the face again because all I taught you in the first part of wireless attacks is how to log into a wireless network. That was the entire thing about wireless hacking. You're not even close yet to actually the exploitation part, not yet. But the fundamentals. Yeah, so without learning how to do these, even if you pwned the router, you're not going to get very far in your penetration test as a so-called red teamer. Not yet. But the fundamentals of every cyber attack often involves the control of a reverse shell. Well, there's two kinds of shells. There's bind shells and then there's reverse shells. Generally, you haven't seen a bind shell since the days of Windows 95 when some fat kid could just press enter and then he just pwned someone's through Windows MSN Messenger or something. So we're skipping bind shells, unless you actually have a zero-day exploit or something. The main thing about reverse shells is persistence. Persistence, the ability for the reverse shell to survive a reboot. Because in order to make reverse shells stealthy, we cannot touch the disk. Not yet. Not until we get administrative privileges. So we have to escalate privileges to for Windows it will be system or domain, and for Linux it will be root. And Mac, I don't know. It's probably root. In case you're wondering, it's pretty hard to find an Apple exploit because they pay a grip of money for bug bounties. And usually, they often honor what they say. It's not like some lousy gold star. It's actually like real money they're paying you, like $100,000 if you find a zero-day exploit. So it's kind of hard to hack Apple devices, but that doesn't mean that they're immune. Not by a long shot. These things can sell for millions of dollars in the black market, like the real deal in the Tor network. So don't think that you're immune. Now, after persistence, we have this is the fundamentals of all reverse shells. The most basic reverse shells can be formed by a program called netcat. It's an unencrypted program. It's mainly meant to be testing network connections and how it could work and interact. You actually have to hand over the shell to the attacker to get a netcat session. Then we have bash. Bash as in the shell that we as Linux users use, or sometimes you probably use Z shell or shell, just standard shell. There's actually a command to create a reverse shell back to the attacker through that. So you can just create a payload that just uses the most basic Linux commands to connect back to a Metasploit session, and then you can upgrade that to an interpreter. We also have router-specific exploits, all right? So it's called MIPS or, MIPS LE. So MIPS, the LE stands for Little Endian, an encoding standard, or MIPS Big Endian, BE, Big Endian. Both of these, even your machines right now, your laptop, your cell phone, they're operating on some sort of Indianness, as they call it. It's the way that the architecture works. You have to understand how to encode or cross-compile a router-specific payload or a device-specific payload. Because when we're hacking Android devices behind the network, it would require some form of encoding, to make it compatible. Otherwise, it'll crash. We also have awk or AWK. Now, the difference between grep and awk is that awk sorts strings vertically, sorts data vertically, and it can print by columns, while also awk can create reverse shells, unfortunately. Telnet. I don't think anyone ever uses Telnet, but you can actually enable Telnet on a Windows machine, creating a route back to a Windows 10 professional machine with Telnet. So you can just log back into the victim's router. Log it back into the victim behind the router, assuming they're using Windows, and has Telnet enabled. SSH, we all rely on SSH to do the fundamentals of moving, files through SFTP or SCP, or to log in, or to create proxies. SSH is a really versatile command, and there is a way to create a reverse shell for that. Meterpreter is Metasploit's upgraded RAT, remote administration tool. Everything I mentioned before, and what I'll mention later, can be upgraded to a Meterpreter shell. We also have Puppy. It's an independent remote access Trojan. And, man, this is a lot. Puppy is, I wouldn't say they have good pivoting modules, but they have really good Windows-specific exploit modules. As in, if you want a total ponage of a Windows machine, you probably want to use Puppy, and it's actually harder to detect because it's not commonly used compared to Metasploit. However, if you want to jump from one Windows machine to another Windows machine, or to the router itself, or any embedded device, you probably want to switch over to Meterpreter by throwing the shell through Puppy and then executing the Meterpreter shell. Because at that point you already have system level root, you probably already killed off the antivirus, firewall, even use PowerShell payloads to, forgot about it. Even use PowerShell commands to, permanently kill off the firewall and ensure that you have a way back. You can then just throw in a Meterpreter shell. So now you can start scanning for people through that session to hunt for other victims. Ruby shells. There's shells in Ruby, and in our Python coding exercises, we have ways to create reverse shells in Python. These are all just one-liners I've pulled from books. There's no difference between each rat or reverse shell, aside from the fact that they all work on the same principles as a netcat example I'm going to show you later on, just as soon as this video is done. They all work the same way. We all have a listener, we all catch the shell, but things like Puppy and Meterpreter and PowerShell and Power Payloads are just much better, more powerful reverse shells with better features. They can all be upgraded. Node.js. Now, JavaScript shells were kind of iffy because it's kind of hard. It's like an arms race between, the developers that are spearheading ECMA 6, ECMA 6, ES6, and the people that are trying to exploit it. JavaScript is generally an outdated language with lots of bugs. It would enable cross-site scripting. For example, if I see an input box or a URL box that actually accepts certain input, I can make it pop alert boxes that will show that I could probably store a payload on a client. If I locate a I look great, but the freaking board sucks, man. Cross-site scripting is generally through JavaScript, Node.js, jQuery, Ruby on Rails, Python Django, or PHP, any web app framework. Okay, I'm running out of breath right now. We also have more basic shells. We have the standard shell, Unix shell, SH. It's generally difficult to work with. We also have harder to work with shells that are just for routers, and they're very common routers called ASH or Dash. But if we were to get full administrator access, we can just simply replace it with our own custom router firmware that would have something like Python or something easier that we can work with. So we can just bypass that. Ash and Dash, you probably want to stick with a MIPSB or MIPSLI payload. Now, we also have to do pivoting. Oh man, I'm running out of breath. I gotta pop these off fast. Pivoting by local port forwarding. That's actually another way of saying Metasploit port forward. You can do that with SSH. Remote port forwarding, same thing, but you can do that in SSH. Administrator port forwarding is really funny because once you install custom firmware, you have the administrator password, you changed it, you locked them out. You can now change the on the GUI, on the browser setting GUI, how to open up a public IP address port remotely and then route it right into someone's computer behind that router into a port that their local machine is. I'll explain how that works. That's probably the first thing I'll talk about in pivoting because this is funny. This is basically showing you how absolute your control is until they buy a new router. Credential reuse. The same password you use to log into the network or is probably going to be used, on the first machine that you pwn, and then from that machine, You can just steal the SSH creds, the keys, the public keys. Reuse those public keys. Maybe you'll even take out like 20 machines at the same time, just because they all run the same keys, they never rotated them, or they use the same password. Proxies. I mentioned proxies twice, but basically you can use proxies to pivot by pretending to be another machine, assuming they left an open proxy that would reveal you more information about the next target. Spear phishing, the difference between phishing and spear phishing is that spear phishing is catered. You would actually know someone's name of the target. You would actually know some personal details that will convince them to click on the payload. Add user. Funny enough, some machines will let you add a root user. You know, that guarantees that you're coming back. Dynamic port forwarding, this is what we'll primarily rely on for tunneling, for proxy chains, is dynamic port forwarding through SSH. Every Linux machine has SSH, and every Windows machine has some form of PowerShell. Alright, it will always work. Or Telnet. This is actually the same thing as proxies, impersonating trusting machines, but there's other ways, you know, like NetBIOS spoofing. You know, you can record all the MAC addresses of the network that you're scanning. Hyperjumping. I already talked about hyperjumping before, but basically, to reiterate, we're going to leap out of our own VM, and then we're going to attack machines through the real network. And hyperjumping technically was the way I was doing things throughout the entire course, how I was explaining. I had a Kali Linux machine, right? And I have a Debian host. I'm going to leap out of that into another host, or leap into that into the Windows target or something that I was creating. Name Piper shares. This is actually a very unique thing for Windows only. Server message block. Server message block, SMB. There's a lot of exploits just for server message block. In case you're wondering what a pipe is, it's just a file that you write to. It's just some file. It could be a temporary file that will disappear when you disconnect the pipe, like a make a first in first out McPhee file, or it could be an actual text file. Exfiltration. You don't want to get caught up, do you? I mean, you can encrypt, which would obviously encrypt the traffic. That can help you defeat the intrusion detection or prevention systems. Obfuscation will change the nature of the traffic, so it's not going through SSH. It's probably going through what looks like VoIP, or voice over IP, or an email message, or an instant messenger program. People don't realize this, but when you're on Facebook Messenger, you have like 20 freaking IPs going through Ireland and all of these Facebook, servers. You can make, through obfuscation, look just like that, so you don't get caught up as fast. Tunneling. Tunneling creates either temporary static routes through some protocol like SSH. I have a lot to talk about tunneling. I'm pretty sure the web application pen tester guy has 1,000 times more to talk about, because web application pen testing is really huge. Okay, they need to have like sub-disciplines for that. What else I gotta talk about? Credential harvesting, detecting or escaping sandboxes. What is a sandbox? Well, basically you just went to jail, for IT. You don't even know that you're in a virtual machine unless you run certain modules to test it. You're basically locked in a prison, and the longer you're in the sandbox, the more likely they'll figure out how your shell works, which means you're compromised. It will be shared on VirusTotal. It will get pushed to Windows Defender on the next patch update, and now your shell and your fancy exploit is screwed. So you better detect whether or not you're in a sandbox. You better learn to kill off your shell immediately, or put it to sleep when it's in a sandbox, okay? Because generally this is game over. Alright, tactics, cross-site scripting, abbreviated as XSS. Cross-site request forgery. Well, you can forge certain headers, URL headers, or cookies that you get from certain secure websites. You might tell you more information. SQLI is SQL injection. Let me just click on that. This is funny because there's actually a framework called SQL Map, and there's actually a one-liner, a massive 20-page one-liner that will try all the tamper scripts. That means it will encode your commands in certain ways that will get it past the web application firewall. And You can just one-shot it, basically, if it was vulnerable. Shell injection, there's numerous ways you can do shell injection. Maybe the guy was an idiot and ran a web server that had a JavaScript console. Proxies, like I'm just saying that again, it's another tactic. We can impersonate someone else's IP address through an open HTTP proxy or a SOCKS proxy. Or if we already pwned somebody through SSH, we create a SOCKS proxy out of them, a SOCKS 5 proxy. Let's see, we already mentioned replace firmware, session hijacking. We can already do this through a Mono Toolkit. Basically, if we were on the same network and then they logged into us, we can then look at their cookies in clear text. We replay the cookies to log into their Facebook account, change the password, now we got their Facebook account. DNS reconnaissance. This is DNS recon. You'll actually get a better perspective of any domains that the wireless network, the owner may have. Any website domains. It's important to do DNS recon from the perspective of our targets because we might learn so much more. Cross compilation. We already mentioned that. Basically, we're just making some payload work with another device that's not x86 Windows or Linux machine. And congrats, at least you scored some free internet, right? At least you scored some free internet. I'm keeping up to my promise. I'm going to show you all about this. Welcome to Cyber Warfare Instructor Part 2. I'm going to die now.